aficionados. Welcome to my channel, Learning Valence Life. Today we are going to talk about electron distribution and chemical properties. So let's begin. Firstly, we will talk about the chemical properties. From where does the chemical behavior actually depends on the electron distribution. Chemical behavior is actually related to the electron distribution of an atom. Atom depends on electron distribution. Now you might think that we can build elements, like from hydrogen we can go to helium by just adding, like atom means like electrons or protons, and also we can take care of the number of neutrons, but it just doesn't happen like that. We have to take care of how the electrons are distributed in that atom. So now I will draw the elements and their electron distribution from atomic number 1 to atomic number 18 in the form of the periodic table. So the first two elements, hydrogen and helium, they are on the first row because they only need one shell to accommodate all of their electrons. And actually, since I explained in the previous episode that electrons were the main reason means they actually were taking part in chemical reactions, the main parts are the electrons only. Now we can move on to drawing those. Firstly, hydrogen. That is just having one electron. I will represent the nucleus as a hollow circle and the electrons as dots, means like this. Okay. And helium on this side is having two electrons. So like that. Now, every orbit or electron shell has its capacity of holding electrons. In case of the first shell, that is the closest to the atomic nucleus, that can only contain two electrons. So any element which has electrons more than two, they will have to go to the next shell. In case of lithium, let's see lithium next. Lithium is, this is the atomic nucleus, and here is another shell. Here 2, and here 1. So like that. This is a bit clumsy, but just bear with me. Lithium, then we move on to beryllium, which has its atomic number is 4. Beryllium. This we'll have like this. Four electrons. Moving on to boron, that has 5. Like this, and then we move to this side. Remember, the first shell can only fit 2 electrons. And when we reach to neon, we will see which is the limit of electrons that the second shell can hold. Then we have to move to the third shell, boron, carbon, that has 6 electrons. carbon, nitrogen, that is 7 electrons, four, and here we form this, and then over here we have 1. This is nitrogen, oxygen, eight electrons, two here, and 6 on this side. So like that, like this, and this is oxygen. We can just count that and check one more time. 1, 2, 3, 4, 5, 6, 7, 8. Fluorine. It has 9 electrons. And neon. This row ends. Here we reach the highest limit of the second shell, that is 8 electrons. We completed this row. Now we can move on to the third row. This is actually the first row, which has the first shell. Second shell. And now we will move to the third shell, but let's line up with lithium, that is sodium. Over here, it has 11 electrons, which is exceeding the 10 electrons. Means this has 10, which is exceeding the 8 electron limit of the second shell. So we have to go to the third shell. Let's draw that. It has to be drawn bigger. 1, 2, 3, okay. 2 here, sorry. Like that over here on the sides. And here 1. Sodium. Magnesium. Twelve. So let's see. Just make some place. That's magnesium. We can just count and check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 1 minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 electrons over here. Then we move on to aluminum. It has 13 electrons. Sorry. Over there we have 1, here 1, and here 1. We can just count that and check. Since the number of electrons are increasing, I'm counting and checking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here we have 13 electrons. Moving on to silicon. That has 14 electrons. Silicon. Now we can check if there are 14 electrons or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, we have 14 electrons over here. Silicon. Phosphorus. That has 15 electrons. Now we can check if there are 15 electrons or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, we have 15 electrons over here. Moving on to sulfur, that has 16 electrons, obviously. One minute. Yes, 2 here. And we draw like that. Like this. Sulfur. Sorry for the clumsy drawing, but it will get better. Now we can check if there are 16 electrons over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, and we are missing. This is the reason we should count and check. So we can add one more here. Now let's check if we have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh. That was an error. Okay. Sulfur. Moving on to chlorine. Which has 17 electrons. 2 here. 2 over there. 2 over here. 2 over here. And 1 here. Now we can check if there are 17 or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, since there is no place for argon, I will have to go over here, but just remember that argon is actually supposed to be here only, as per the periodic table. Argon. That has 18 electrons. here 2. Now we can count and check if there are 18 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are perfectly 18 electrons over here. This is the electron distribution, means this whole periodic table which I've drawn till the atomic number 18 from 1. That is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. I have shown the electron distribution of all of these elements. So now you can take a look at the board. Moving on more about chemical behavior. We'll talk more about this topic, electron distribution and chemical properties. In the previous screen, we saw the periodic table that I've shown the electron distributions. Now, what is the main thing? Which are the main electrons which take care of this chemical behavior? Chemical behavior depends on mainly the valence electrons. Mainly depends on the valence electrons. Which are present in the valence shell. Let's say two elements have the same number of valence electrons, and a very prominent example is fluorine and chlorine. Fluorine and chlorine. This is F and Cl. Both of them have 7 valence electrons. 7 valence electrons. They can form compounds. Both can form compounds with sodium. For example, sodium fluoride, that is NaF, sodium fluoride. NaF. Na is for sodium, that is natrium actually. It's basically used in toothpaste to prevent tooth decay. And we have discussed previously about NaCl, that is common salt, common table salt. Sodium chloride. NaCl. The valence electrons are very important in case of the chemical behavior, and we saw if, let's say it had the same number of valence electrons, it could form with sodium, both of them. Sodium fluoride used in toothpaste and sodium chloride used as common table salt. Now you may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you!